Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video, we're going to take a look at how we can use prime factorization to help us find the lowest common denominator when we're adding and subtracting fractions. So we need to talk about what factoring means and what prime numbers are first. So if we talk about factors, let's take a look at an example of, let's say, 24. We know that 24 is equal to 2 times 12. So 2 is a factor of 24. 12 is a factor of 24. There are other factors. 24 is also equal to 4 times 6. So we would say that 4 is a factor of 24. And 6 is a factor of 24. There's other ones as well. 24 is also equal to 3 times 8. So 3 and 8 are both factors of 24. 24 also has the factors of itself and 1. So some numbers have lots of different factors, and some numbers don't. Some numbers only have itself and 1 as factors, and those are very special numbers. So I want to talk about those next. So the special number I want to talk about is called a prime number. And the definition of a prime number means that it only has 2 factors, itself and the number 1. So let's take a look at numbers 1 through 20. Just to find out which of these are prime numbers and which are not. Some people think 1 is a prime number, and I don't want to get too technical here, but really 1 only has 1 factor, and that's the number 1. So technically it's not really a prime number. 2 has 2 factors, 2 and 1. So it is a prime number. 3 only has 2 factors, 1 and 3. It's a prime number. 4 has other factors as well as 1 and 4. 4 has a factor of 2, therefore 4 is not prime. 5 only has factors of 5 and 1, so it is a prime number. 6 has more factors than 6 and 1. 2 and 3 are both factors. We can write 6 as 2 times 3, so it's not prime. 7 is prime. We can only express 7 as 1 times 7. 8 is not prime. It has factors of 4 and 2. 9 has factor of 3 as well as 9 and 1. 10 has a factor of 2 and another factor of 5. 11 doesn't have any other factors other than 11 and 1. 12 has other factors. 13 does not. So you can see all of our even numbers are not going to be prime numbers because 2 will be a factor as well as other numbers. So 14 is not. 15 is not because 3 and 5 are factors of 15. 16 is not. 17 is. 18 is not. 19 is. 20 is not. And so on. And we can, keep going through our numbers as we get larger and look to see which ones only have factors of itself and the number 1. So we're going to use the idea of prime numbers in order to find prime factors of other numbers. So let's take a look at how we do prime factorization. I wrote those prime numbers on the board just to remind me what prime numbers are. And we're going to take the number 24 and we're going to do what's called prime factorization. So the way that I do it is I look at my lowest prime number, see if it's a factor of the number I'm doing prime factorization. 24 has a factor of 2, so I can write 24 as 2 times 12. 2 is a prime number, so I'm done with that. Then I look at my other factor. If this is a prime number, I'm done. If it isn't, I do the same process with this next number. I start usually with the lowest prime number and see if that's a factor of 12. It is. So I write 12 as 2 times 6. That's a prime number, that's a prime number, so I'm done with those. Then I look at this. Is this a prime number? No. So again, I'm going to write this as a product. Product means multiplication of its prime factors. Is 2 a factor of 6? Yes, it is. 6 can be written as 2 times 3. So this is a prime number, this is a prime number, this is a prime number, and 3 is a prime number. Therefore, I can write 24 as 2 times 2 times 2 times 3. So this is called prime factorization. We took the number 24 and we wrote it as a product of all its prime factors. This is a very useful procedure when you're finding the lowest common denominator for very large denominators. Let's take a look. If I was going to add these two fractions, I need a common denominator. I don't want to multiply 24 times 60 to get a common denominator because then we're getting into a lot larger denominator than what we need. So in order to find the lowest common denominator, we could find the prime factorization for both of these denominators. So 24, we already know, is 2 times 2 times 2 times 3. We do the same process for the other denominator. So 60. Does 2 divide into 60? Yes. So 60 is 2 times 30. That's a prime number. I take 30. I break it down. Does 2 divide into 30? Yes, it does. So it's 2 times 15. That's a prime number. That's a prime number. 15 is not a prime number. 2 does not divide into 15, but 3 does. So I write 15 as 3 times 5. 3 and 5 are both prime numbers, so I'm done my prime factorization. 60 will equal 2 times 2 times 3 times 5. So I have the prime factors of 24 and of 60. In order to find my lowest common denominator, I go through these factors and I start with the 2. So 2 times, now it's in both, so I don't need to use it twice. Then I have another 2, another factor of 2. I have another factor of 2 in 60, so I don't need to repeat it. Times 2, I don't have another factor of 2 in 60, but I still need it. Then times 3, I have a factor of 3. Well, I also have a factor of 3 there, so I don't need to repeat it. And then I'm left with a factor of 5. So what I've done is I've taken a product of all of those prime factors without repeating any. So I didn't need to repeat the 2 or this 2 or the 3. You just need them once. What you're left with will be the lowest number that both 24 and 60 divide into evenly. When I take 2 times 2 times 2 times 3 times 5, I get 120. There's no number smaller that both 60 and 24 divide into evenly. So if you were asked to add these two fractions, you need to change them both to equivalent fractions with 120 as the denominator. What does 24 need to be multiplied to equal 120? It needs to be multiplied by 5. If you multiply the denominator by 5, you must multiply the numerator by 5. So 1 over 24 is equivalent to 5 over 120. Similarly, what does 60 need to be multiplied to equal 120? It needs to be multiplied by 2. If I multiply the denominator by 2, I need to multiply the numerator by 2 as well. So 1 over 60 is equivalent to 2 over 120. Now that I have the same denominator, I can add my numerators. 5 plus 2 is 7. Do you need to use prime factorization to find 120? No. There are other ways, and if you have other methods that work for you, that's fine. I'm just showing you a method that will always work regardless of how large your numbers are. So if you're asked to do prime factorization for any reason, I've shown you the method to do it. And if you need to do prime factorization to find your lowest common denominator, you know how to do that.